we're going to talk about categorical variables. So let's just do a quick review. What is a categorical variable? So categorical variable, the data is, instead of being things that every value is possible, there are just like groupings of stuff. So this, what the book said is that this is, pencil's being stupid, so we're going to use the alternative one. This is raw data. Consists of category names. And they don't necessarily have an ordering. Don't necessarily have an ordering.
Oh.
I don't know why you're being so stupid. Just reset it. Okay, and if these categorical variables do have an ordering, all of a sudden they're called ordinal variables. So ordinal variables are categorical variables for which the categories have an ordering. Why are you being so stupid? Apple, your technology sucks right now. Still sucks. Major fail. This is a categorical variable for which categories have an ordering. And the ordering could be like a ranking system, like you say, I'm going to rate my dislike of candidate X, please don't fill in any names, candidate X on a scale of, 1 to 3 or something like that, like, dislike, strongly dislike, whatever, stuff like that. The variables in the previous section we talked about were quantitative variables, right? Any value was possible in some interval. You can make, lots of times quantitative variables are made ordinal by just saying, okay, you're in this specific group. Like you could be in the age group from 18 to 29, and all of a sudden that is a categorical variable. Does that make sense? And also ordinal because there's an order to these things. So it's possible to make quantitative variables into categorical ones by just designating categories for stuff. If your foot size is within this, you're in this category. So it's not like they're hard, fast things that you're always this, you're always that. You can kind of like fudge things around and change them. And today we're just going to look at comparing two categorical variables. We're going to do this using contingency tables. So this is a table that covers all possible combinations. So table, and we'll have examples that will make more sense. Table that covers all events. Or circumstances for the combinations of the two variables. Okay. And so if you look at the example one, we'll kind of explain a little bit what's going on here. Do you see how in that example I have female and male, and then I have the class. So in that one, there are people that auditioned for an orchestra, and in each class, different proportions of sexes applied for each position. Like you can see that for the freshmen, there are a lot more girls than boys that applied, right? Does that make sense? For the sophomores, it was half and half, etc. So when we look at stuff like comparing freshmen to sophomore to junior to senior. Those are called conditional percentages. So you compute these within the rows or columns, and they're going to mean different things based on what the situation is. So computed within the rows or columns. And which way do rows go in a table? Across? Okay. So this is a percent of a given row where rows go across. A column percentage is a percent of a given column. Where columns go up and down. And what those things mean is going to depend a lot on what the context of the situation is, like what are the specific things we're looking at. Let's see if this is working now. I understand you. Good to go? Okay. Okay, so every fall, auditions for band and orchestra are held at a large university. And last fall, the numbers of males and females in each class who auditioned were listed as follows. So for the freshmen, there were 270 applicants, sophomores 100, juniors 80, and seniors 50. So calculate the row percentage for freshman females and explain what this means. So what this is asking is, look at the freshman row. What proportion of that freshman row were females? 170 freshmen were females out of how many total freshmen? 270. And let's round your percentages to one decimal place. So I got 62.9. Did you guys get that?
Wouldn't it round to 63? Since it's 62.96?
Is it?
Yeah.
Oh, okay, yes it is. It would be 63. Yep, I wrote 62.96 in my notes. Yep. So we'll say 63%. I hate running to whole numbers when they're not whole. Like, you know what I mean? But, or we can say 62.96%. Okay, so what is that telling you? It tells you out of the freshman total, right?
63% and working.
Yep, exactly. So of all the freshmen who applied, I think I just put my H's and my M's as one letter, didn't I? Yeah, sorry. Of all the freshmen who applied or auditioned, 62.96% were female. Okay, that's not so hard, is it? Okay. Calculate the column percentage for freshman female. So instead of taking the total out of the row, take it out of the column. So that's going to be 170 out of, And so I got that was 56.7% or 67%, 56.7%. So out of the total, so what is this telling us? So out of all the female auditions, about 56.7% were freshmen. So the first one was an example of a row percentage. This is an example of a column percentage. Does that make sense? Okay. Ready for part C? Okay. It asks which class had the highest percentage of female applicants. Support your answer with numbers. So I think to actually compare them, you're gonna have to figure out the percentage of female applicants for every single class. Does that make sense? And it's not super bad, right? I think we did the first one already, right? So for the first one, what was the percentage? Like about 63%? Yeah, about 63%. This next one's easy. It's 50 out of 100, so it is 50%. This next one is 60 out of 80, right?
75.
Which is 75%. And the last one is 20 out of 50 or 40%. Yeah, so the junior class was the highest with 75%.
Is that what you for supporting our answer with numbers?
Oh man, it just depends. I mean, it's so hard for my grader to grade 64 papers, right? So what do you think would be best? Compared to? So on my notes, I added this. Compared to 63% in the freshman, right? What's the rest? 50% in sophomore, right? And 40% in the senior class. How I would handle that, like on a quiz or a test, is I'll probably just ask you to find all the row percentages, and then you can just tell me which one's the best.
Since the work will be showing anyway.
Because it was my work anyway, right? But on this thing, when I have the TA graded, I'll probably just have her check that you have the right class and the percentage. Does that make sense? Because there's just so much for her to check, and it can be, it's really hard to legislate like what exactly I want from you so that you all do it. I don't want to be an uber meanie, but it's hard. Notoriously vague way to ask the question, so I'll make it not vague on tests. Is that all right? Okay. And the question is, which sex had a higher percentage of sophomore applicants? So there you're comparing males to females, so are you looking at rows or columns? Columns. Okay, and this one there's only two numbers, so it's not as hard to support, right? So for the ladies, how many were sophomores? So 50 out of 300, which I got was about 16.7%. Okay, great. And for the males, we had 50 out of 200, right? Exactly 25%. So, Gesundheit. So the men did, right? And in that case, there's your numbers, right? Is that okay? So much like the previous sections, like in chapter 3, you can only make scatter plots if you have quantitative variables. If you're going to do two-way tables, you have to have categorical variables. Okay, so what this question is asking is, tell me if a two-way table is appropriate. It's that thing that we were just discussing. and briefly explain why or why not. So the kicker for this situation is things must be categorical. So is political party and opinion about a new gun control law, are both of those categorical variables or not?
Yes.
Yes. And nothing says there have to only be two categories either, right? So, political party could include Democrat, Republican, other Libertarian, Green Party, and then also a undeclared also could kind of be its own group, right? So, as long as there are sort of semi-distinct categories, one rule is you can't be in more than one. Okay, just to pick one category. Okay, how about weight in pounds and height in inches? No. These are quantitative variables, or these are not categorical. You could imagine a way to make it so is to sort of like make boxes. If your weight is between like 10-pound increments, and you put people in categories that way and put their heights in 1-inch increments by rounding, you could make them categorical by doing that. But since they didn't specify that that's what's supposed to be done, they're not categorical. Okay. And so some kind of things you can do here is you can look and see, are groups of people treated differently, and maybe is this treatment based on this attribute that we're looking at or not? So there was a study done in England, this Voss and Mulligan person, they collected data on height, and they classified somebody as short or not short. And I don't know if I didn't specify what that criteria was, but they had some criteria. If you fell below this height, you were short, and above that height, you were just not short. And they suspected that the short kids were going to get picked on more. And so they asked these kids if they had been bullied. And so there were 209 people, and you see how they fell into different categories. And I suspect that what they did is they probably set their threshold for short by trying to keep the categories kind of even. Because you can see that the short and not short, they're kind of close together, right? Okay. Yeah, look, I said this. Researchers intentionally sampled the way that made the short students constitute almost half of the sample. That's how they did it. So write a sentence that explains what will be measured by the row percentages. Make your answer specific to this situation. So if you look at the rows, if I did 42 out of 92 as the percent of short people who are bullied, right? Yeah. And then 50 out of 90 is the percent that are not bullied, right? Versus 30 out of 117 is the percent of not short who are bullied, right? So it's finding the proportions of people who are bullied or not bullied within the two categories. Does that make sense? Let's see. So the row percentages tell us what proportion of each group say short versus not is and is not bullied.
And that would suffice as an answer, you don't want any real numbers there?
No, because we're going to find those in the next question. Yep. So yeah, there's no need to find numbers, but you could, if you want to be more specific, you could say, okay, for example, if I compute the row percentage for the short people, 42 out of 92 says that this percentage of people are short. But usually, just to make it easier to give partial credit, I'm going to ask questions in a pretty specific way. Okay, so the next one says to actually find those row percentages. So we'll say short. That's kind of trippy. So you have short. Come on. And then not. Yes and no. So what out of what would you do to figure out the proportion of short people who say yes, they're bullied?
42 out of 92.
42 out of 92, which I got was about 45.7%. And the other one is 50 out of 92, which is 54.3%. Yep. Not actually better. Okay. Are the numbers going to be different for the not people? Yeah. So this one's 30 out of 117, which is and how about the not shorts? That'd be 87 out of 117 or
74.
So does it look like the short kids are picked on more than the not short kids?
No.
You don't think so?
Oh, yes, sorry.
That's okay. No, it's all right. Yeah, I think it sure does, right? Like it's like 20% more in that whole
Yeah.
like short group, right? Those poor little kids. Okay, part C says to draw a bar graph of the row percentages. So mine's on the previous page, but yours is right above. You guys okay?
Yeah,
Oh,
we're
yeah.
just,
Did you do them the other way or?
we were thinking about how, sometimes short people, like, it just sounds different, I don't know how to explain it.
It's kind of like attitude, but like tall people might not perceive that as boring.
Oh yeah, there definitely are
It's like
certain
the
things.
gentle
Yeah. There definitely is a little bit of like ambiguity as to what constitutes being bullied.
Yeah.
Is that what you're saying? Yeah, totally. No, yeah, we're not going to discuss that because that's like.
Yeah.
We will discuss proper experiential design though in the next chapter, so we'll get there next week. Okay, so let's make a bar graph. And it's going to be kind of like 2 bar graphs. Actually, it's a lot like that bar graph I showed in the first day of like the groups of people that had certain homework scores and their grade in the final class, like their percentages, or it was very something quite similar to that. So we have the short group, and then we have the not so short group. And I'm just going to make a key, which you could do on your own, but I'm going to say filled in means yes, they were bullied, and a blank circle means no, they're not. And I'm just going to count by tens. 10, 20, 30, 40, 50, 60, 70. So percent by 10%. So what proportion of short kids were bullied?
35.
So almost a 50. So 10, 20, 30, 40, 50, about halfway. And I'll fill that one in and say, yes, they were bullied. What percent of short kids were not bullied? 54. So just a hair over 50, like halfway to approximately halfway. So there's how my 2 categories stack up in the short. How about in the not category? What proportion of the not kids were bullied? 25, yeah, just a hair over, so. Versus 75-ish, right? Okay. So does that picture suggest that there's a difference in perceived bullying in those groups? Definitely, right? So that's what the next question asks you. Is there a relationship between height and the likelihood of being bullied? And I would say like, what, yes, right? There seems to be. as short kids were, we'll put bullied in quotes, because we don't really know what that means. About 20% more than the non-shorties. Very technical term there. Now, it's at this stage in what you guys are doing, it's a bit ambiguous as to how big a difference needs to be before it's a big enough difference to mean anything. Does that make sense? Like 20% is pretty large, but is 10% big enough to be an actual difference? Or is 5% big enough to be an actual difference? Like, the point at which that difference is important or big enough kind of is a moving target. Does that make sense? And it's a moving target that's based on a couple things, one of which is how big the difference is, like how much percent different they are. And the other thing has to do with how big your sample was. If you only sample a small group of people, it's really easy to get really different perceptions about those two groups, right? But when you have bigger groups of people, then if the things are 10, 20% apart, it usually means that this is a difference that's significant. We'll learn a way to test that on Friday, okay? But for now, if it seems big to you, just explain you think it's big, okay? Yes? Or just stretching, okay? Right. And then the last question is that an important objective of statistics is to use the sample to make information about the larger population. What is this population? Like, can we generalize this to all school kids everywhere, or just a specific group of school kids?
Probably specific.
Somewhat specific, right? Because at least that much is true, right? So probably secondary school kids in England, right? Does that make sense? Like probably, and maybe even that might be pushing it a bit, but definitely not secondary school kids everywhere, right? Okay, so probably, yeah. They did say it, didn't they? Yeah, probably secondary school, fancy word, pupils in England. Probably is the population.